Effects of pinned memory on performance. As explained in the previous section, the pinned memory may make a non-negligible impact on the overall performance of large-scale simulations. A. Shows the performance measured with the pinned and pageable memory at a 70%, K40, and 90%, P100, GPU load, where a single computing node is used with the warp-2 kernel and texture memory. The CPQD has 30 times 80 times 80 unit cells. Results indicate that the case with pinned memory shows better performance than the one with pageable memory due to the following 2 points. 1. The reduction of copy on time due to the increased bandwidth of PCIe bus with pinned memory, and 2. SBMV plus copy out time as communication hiding behind the computation. We observed the effective bandwidth of PCIe communication is 3.31 GB per second with a pageable memory on every testbed, while it reaches 10.40 GB per second with a pinned memory, driving 3.14 speed up in data transfer. The effective speed of SBMV operations increases by a factor of 1.36 and 1.19 with pinned memory compared to the speed with pageable memory at the K40 and P100 testbeds, respectively, since utilization of the pinned can overlap computation and data transfer. The performance for end-to-end simulations therefore becomes 1.27 and 1.21 times faster with pinned memory against the performance obtained with pageable memory at 70% GPU load, K40, and 90% GPU load, P100, respectively. Performance measured in a single computing node for end-to-end simulations of 30 times 80 times 80 unit cells at the optimal GPU load, 70% for K40 and 90% for P100. A. Performance measured with the pinned and pageable memory when the warp-2 kernel is used. B. Performance of 3 different SBMV CUDA implementations. SBMV calculations are slightly accelerated with utilization of the texture memory. Though here we only focused on the performance of PCIe communications, it is possible to estimate the performance benefit that may be obtained with NVLink communications. For this purpose, we investigate how the bandwidth of communications between CPU and GPU affects the overall performance, where we find that the overall speedup is 1.21 times due to the 3.1 times enhancement of PCIe bandwidth on the effects of pinned memory in PCIe AD and P100 devices. Because the bandwidth improvement with NVLink connectivity between CPU and GPU is 3 times compared to the PCIe, we may roughly expect that there will be another 1.06 times speedup for the end-to-end simulation with NVLink AD and P100 devices.